Welcome everyone. Here in the previous class we have seen what is photosystem, what actually is a photosystem. So this photosystems helps in the process, they help in the process of photosynthesis. Now these photosystem is nothing but it is this antenna complex plus primary electron acceptor together is called as photosystem. This what here antenna complex plus primary electron acceptor together is called as what? This complex, this whole is called as photosystem. And we have two types of photosystem, that is photosystem 1 and photosystem 2. Photosystem 1, it absorbs wavelength of 700 nanometers, and photosystem 2, it absorbs wavelength of 680 nanometers. So now till this we have seen this, what is photosystem 1, photosystem. Now let us see how this reaction of photosynthesis is carried out. How photosynthesis is carried out. So photosynthesis is carried out in two stages. It is carried out in two steps. The first step is called as the light reaction and the second is called as dark reaction. This whole process of photosynthesis is carried out in two steps or in two stages. The first one is called as the light reaction and the second one is called as the dark reaction. Light reaction and dark reaction. So let us see what happens in this. So here this light reaction, why it is called as light reaction? Because here for these reactions to be carried out, this first stage of photosynthesis requires light. In the absence of light, these reactions or the process cannot be initiated. Because to initiate the process of photosynthesis, that is the first stage of photosynthesis, light is very much essential. So here these require light. These reactions or the stage requires light. So that is why these are called as light reactions. Okay, and we can even call it as Hill reactions. Light reaction is also called as what? Hill reaction, because it was discovered by the scientist Robert Hill. It was discovered by the scientist Robert Hill. So that is why they are also called as Hill reactions. Light reactions because they take place only and only in the presence of light. So that is why these are called as light reactions. And the next stage, the second stage of photosynthesis, it is called as the dark reaction. It is called as dark reaction. Why dark reaction? If the name is dark reaction, that doesn't mean it only takes place in the dark. This means that these reactions are independent of light. Light reactions are light dependent reactions. They require light. In the absence of light, these reactions cannot be carried out. But dark reactions, they can be carried out in the presence as well as in the absence of light. So this presence of light and absence of light doesn't bother. So here in the absence of light also dark reaction will be carried out, and in the presence of light also dark reactions can be carried out. So these dark reactions, they are independent of light. If it is good, if it is there, then also no problem. If light is not there, then also no problem. So here dark reactions can take place in the presence and absence of light, but light reactions, they take place only in the presence of light. So light reactions are light dependent and dark reactions, they are not dependent on light. Light reaction is also called as Hill reaction because of the scientist which discovered it, Robert Hill. And this dark reaction is also called as Calvin cycle. Calvin cycle, because it was discovered by the scientist Melvin Calvin. So that is why this cycle is also called as Calvin cycle. Now let us see this one by, that is first stage of photosynthesis, that is the light reaction. What happens in this light reaction? What actually happens in the light reaction? In the light reaction, many events will take place. Many events will take place during this first phase of photosynthesis. What happens is here absorption of light. The first thing which happens is absorption of light. Light will be absorbed. The second thing which happens is light absorption will take place. Then here splitting of water molecule take place, and this formation of intermediate products, formation of that is high energy intermediate products will be formed. So that is ATP, NADPH will be formed, and most importantly here it also releases oxygen. During this stage oxygen is evolved. So here this light reaction or this first phase of photosynthesis, so it involves various events, that is in the light reaction absorption of light take place, okay, release of oxygen take place, and formation of high energy intermediate compounds such as ATP and NADPH will be formed. And here last but not least, here splitting of water molecule takes place. Splitting of water molecule takes place. So these are the various things which happens during the light reaction. And here now you understood why this light is essential. The first thing which happens is absorption of light. Light is absorbed, and for the light to be absorbed, light should be present. In the absence of light, what will be absorbed? When light is there, then only plants can absorb the light, then only pigments can absorb the light. So that is why these reactions, these are light reactions, that is these are dependent on the light. When there is no light, no absorption. No absorption means following events will not take place. So that is why these reactions are light dependent reactions. Now let us see what happens during this. We all know what is this photosystems and what is photosystem. Coming to this, let us see what happens in this light reaction. So here we have photosystems will be present, that is photosystem, chlorophyll A, and we have this light harvesting complexes are there. Light harvesting complexes are present. Okay, this light harvesting complex, so when the sunlight falls on it, so here this one, this photosystem 2, it absorbs the light of 680 nanometers. So here when the sunlight falls on this one, this together, this reaction center and this accessory pigments, they together make the antenna complex or light harvesting complex. That is, they absorb the light, they absorb the energy from the sunlight. So what they do, light harvesting complex means they will be absorbing the sunlight. So what, these pigment molecules, this is accessory pigment and as well as this chlorophyll A, all of them absorb the energy from the sunlight. That is, all of them absorb the energy from the sunlight. So what wavelength it absorbs? The 680 nanometers. It absorbs the light of the wavelength 680 nanometers. So what happens when it absorbs, when this chlorophyll A gets the energy? So what happens? Chlorophyll will eject one electron. Chlorophyll will eject an electron. So that will be accepted by primary electron acceptor. primary electron acceptor. So first thing which happened in light reaction is absorption of light. We have seen the events. Now what happens here? Absorption of light, then splitting of water, release of O2, oxygen, and formation of ATP and NADPH. These are the different events which takes place during light reactions. So what happens? The first thing is absorption of light. What happened is absorption of light. So here light has been absorbed. Light of this 680 nanometers wavelength has been absorbed by this reaction center chlorophyll A as well as this accessory pigments. Now because of this energy, the chlorophyll gets excited and ejects one electron, and this electron will be accepted by primary electron acceptor. Okay, now from here this primary electron acceptor, the electron is passed. The electron from this chlorophyll, it is moving to this primary electron acceptor. It won't stay here. So what happens? From this primary electron acceptor, it moves on to different electron acceptors. So it moves to different electrons acceptors. Okay, so one by one. So here this electron from chlorophyll, it will move to its. Here this chlorophyll gets excited. What happens? Because of the sunlight, chlorophyll gets excited, an electron will be ejected from, that is, it will be moving into another orbit which is far away from the nucleus. The electron which was present near this orbit, near this nucleus, it moves away. It moves away into another orbit where it will be accepted by primary electron acceptor. And from that primary electron acceptor, it passes that electron to another electron acceptor. This is another electron acceptor. So from this, it will pass on to another electron acceptor, and from here it will pass on to another electron acceptor. So like this, the electron which has been ejected by the chlorophyll, which has been accepted first by the primary electron acceptor, moves on to different electron acceptors. So through this, so this one is called as what? Electron transport chain. So the electron is transported from chlorophyll A to primary electron acceptor to a series of electron acceptors. What are these all? Electron acceptors. Okay, so they will be accepting this electron. For example, this is the electron which has been ejected. It is accepted by this one. Now this primary electron acceptor will pass on this to another acceptor, acceptor 2. Acceptor 2 will pass on the electron to acceptor 3. Acceptor 3 will pass on the electron to acceptor 4. So like this, the electron moves through a chain of electron acceptors. So this chain is called as electron transport chain. The chain in which the electron is moving from one acceptor to another acceptor. So this is called as electron transport chain. Okay, so finally, so these are the cytochrome complexes. So now here, when it comes to this one, so what happens here? Now this electron, instead of going to another electron acceptor, it moves on to photosystem 1. It moves on to photosystem 1. The electron will be accepted by photosystem 1. Here, this is the photosystem 2. For the process of photosynthesis, I said you, two photosystems are involved. So now this electron will move to photosystem 1. So this is chlorophyll A, and these are the accessory pigments. These are the accessory pigments. So now this electron will be accepted by this photosystem 1. The electron will be passed on to this photosystem 1. So now the electron which was ejected by this chlorophyll has moved on to this primary electron acceptor. Now from primary electron acceptor, the electron has passed on to different electron acceptors, different through a chain of electron acceptors, finally being accepted by this chlorophyll. Finally being accepted by this chlorophyll. So now when this chlorophyll, the electron is with this chlorophyll. Now here what happens when the sunlight falls on this chlorophyll also, because this photosystem is also here also, they are also capable of absorbing the sunlight. So here now it is photosystem 1. So what wavelength of which 700 nanometers. It absorbs the sunlight of the wavelength 700 nanometers. So what happens? Electron has been accepted by this. Now before, let us see this one. So what happened is, electron here, these two photosystems are there. These two photosystems are there. Now here, let us forget this one. Let us forget this one. We are talking about this now. This is one photosystem, this is photosystem 2, this is photosystem 1. On both these photosystems, sunlight has fallen. Okay, sunlight has fallen. This photosystem will absorb the sunlight of 680 nanometers and this photosystem will absorb the sunlight of 700 nanometers. So when it absorbs the sunlight of 700 nanometers, so what happened? It will eject one electron which will be accepted by primary electron acceptor. It will be accepted by primary electron acceptor. Okay, now from this primary electron acceptor, it moves on to another acceptor, another electron acceptor, and finally it will be taken up by another electron acceptor, that is NADP+. It will be accepted by this electron acceptor NADP+. So now this one, light has fallen here, light has fallen here, this has absorbed the sunlight, this also has absorbed the sunlight. After absorbing the sunlight, this chlorophyll A ejected one electron which is accepted by primary electron acceptor A. This also ejected one electron which has been accepted by primary electron acceptor. Okay, now from primary electron acceptor, it has been transported to a series of electron acceptors, cytochromes and all. So here we will see when we study about the cyclic and non-cyclic photophosphorylations. So but as of now, so it will be passed on through this chain of electron acceptors, and from this primary electron acceptor, it will be accepted by another electron acceptor, finally getting accepted by this NADP. It is accepted by NADP. So now what happens? This electron, this chlorophyll has lost the electron. It gained the energy, and in excitement he said, okay, now come and take, I'll give one electron. So it has ejected one electron which has been accepted by primary electron acceptor. Okay, now whatever energy was there, it has been utilized. Now chlorophyll want its electron back. It won't be for a long without the electron, because continuous photosynthesis, this has to absorb the sunlight. So here continuous, it has to eject the electron. So where is the electron? So it should get back the electron, then only it will be ejecting it for the next continuation. So now what happens? This chlorophyll will be wanting the electron back. Because of the sunlight, it got excited and it has ejected the electron. Now it is having one less electron. It wants its electron back. It wants its electron back. So what will happen? From where it will get electron? Because that electron, it will not come back here. It has moved on to primary electron acceptor, and from this it has passed on to a series of electron acceptors, finally given to this photosystem 1. Finally, that electron has been passed to photosystem 1. So now this chlorophyll has got the electron back. When it has absorbed the sunlight, it has ejected one electron. It has ejected one electron. So now electron is less now. That less electron is given to it from this. It has got this chlorophyll A. That is the chlorophyll A of reaction center 1, that is photosystem 1, will get its electron back, because this electron from photosystem 1, from photosystem 2, electron is transported to photosystem 1. This chlorophyll has got its electron. Sunlight, when it absorbed, it has ejected the electron. So it is having one less electron. So what happened? It gained the electron back. How it gained? Because from here the electron has been given to this chlorophyll A. Now that ejected electron has been again given to this chlorophyll by this photosystem 2. Now this is complete. It has lost the electron as well as now it has gained the electron through this photosystem 2. Now this has also ejected the electron, but this has not got the electron till now. This has not got the electron till now. So how it will get back the electron? From where it will get back the electron? It is not now. It is not by primary electron acceptor. It cannot say now I have given you one electron. Now you return my electron back. It won't be like that, because it has already passed to another electron acceptors. So how will this chlorophyll A gets the electron back? So this will be seen in the next video. We'll see in the next video how this chlorophyll A will get the electron back, as well as we will see this non-cyclic photophosphorylation.